Hi, this is the read aloud for Chapter 5, Lesson 2, Volcanic Eruptions. This is not my clump of hair. This is in the book. Sorry, I saw that when I put it up there. It looks kind of gross. It's called a hothead. Hot-headed, can lava look like hair from the top of your head? It often does in Hawaii, so that's what they're showing you the resemblance there. Here, hikers may come across the strand of hard material that shimmer like gold in the sunlight. These thin strands are Pele's hair. Pele is a Hawaiian goddess of of volcanoes and fire. Her hair is actually volcanic glass. It forms when tiny drops of molten lava fly into the air. The wind stretches these drops into threads that are as thin as hair. The glass strands then settle in crevices in the ground, forming clumps. Very fancy. So what happens when volcanoes erupt? Lava begins as magma, so that's underground. Magma usually forms in the somewhat soft layer of hot solid rock that lies in the upper mantle, just below the layer of harder rock. The magma is less dense than the material that is around it, so it rises into the cracks in the rock above. If this magma reaches the surface, a volcano can form. That's 156, 157. Inside a volcano is more than a large cone-shaped mountain. Inside, love this picture of the volcano. Inside a volcano is a system of passageways through which magma moves. A magma chamber. All volcanoes have a pocket of magma beneath the surface, so you can write magma chamber here in your book. They have a pocket of magma beneath the surface. Beneath a volcano, magma collects in a magma chamber. During an eruption, the magma forces its way through one or more cracks in the Earth's crust. Magma moves upwards through a pipe, a long tube that extends from the Earth's crust up through the top of the volcano, connecting the magma chamber to the Earth's surface. So this would be the pipe. So this one right here. Vent. Molten rock and gas leave the volcano through an opening called a vent top. When some volcanoes have a single central vent at the top, but volcanoes often have vents on the sides also. So this would be a vent, this would be a vent, this is a vent. Lava flow. A lava flow is a spread of lava as it pours out of the vent. Oh, I think that was pointing to that one. And then a crater is a bowl-shaped area that may form right here at the top of a volcano around a central vent. So that crater they're showing you right there, you can label that one crater. Very fancy. So this one would be a vent and this one would be the lava flow. So they have all of those right there. Oh, so it's saying a central vent, a side vent. So please put your words in your word bank. 158, a volcanic eruption. Perhaps you know that dissolved carbon dioxide gas is trapped in every can of soda. But did you know that dissolved gases are trapped in magma? Just like pop. This dissolved gas are under great pressure. During an eruption, as magma rises towards the surface, the pressure of the surrounding rock of the magma decreases. The dissolved gases begin to expand, forming bubbles. These bubbles are much like the bubbles in the soda can. As pressure falls within the magma, the size of the gas bubbles increases greatly. These expanding gases exert great force. Think of shaking a can of pop and then you open it. So the bubbles expand because the pressure falls because you've opened the can. When a volcano erupts, the force of the expanding gases push magma from the magma chamber through the pipe until it flows or explodes out of the vent. Once magma escapes from the volcano and becomes lava, the remaining gases bubble out. Two types of volcanic eruptions. Some volcanic eruptions occur gradually over days, months, or even years. Others are great explosions. Geologists classify volcanic eruptions as quiet or explosive. Whether an eruption is quiet or explosive depends on the part of the magma's silica content and whether the magma is thin and runny or thick and sticky. Silica is a material found in magma that forms from elements oxygen and silicon. Remember when we were talking about igneous and sedimentary or igneous and metamorphic rock? These were ingredients inside of them that made them look and create different kinds of rocks. Temperature also helps determine how fluid or runny magma is. Page 189. Quiet eruptions. A volcano erupts quietly if the magma is hot or low in silica. Hot, low silica magma is thin and runny. Think of squeezing syrup, warm syrup out of the syrup bottle. It's not going to explode out of there. It's already thin, it's warm, and you can squeeze the bottle and it'll gently flow out of the top of it. The gases in the magma bubble out gently. Low silica lava oozes gently from the vent and can flow for many kilometers. Quiet eruptions produce different kinds of lava, as shown in figure 2. The different types of lava harden into different types of rock. Pohohi forms from fast-moving lava that is thin and runny. The surface of Pohoho looks like a solid mass of rope-like coils. Aha forms from lava that is cooler and thinner. The lava that Aha forms from is also slow-moving. Aha has a rough surface consisting of jagged lava chunks. Most quiet eruptions form from the Hawaiian Islands, hence the names I just said. On the island of Hawaii, lava pours from the crater near the top of Kilauea. Lava also flows out of the long cracks on the volcano sides. In general, the temperature of magma and lava can range from 750 degrees Celsius to 1,175 degrees Celsius. Just know that it's hot enough to melt copper. Quiet eruptions have built up the islands of Hawaii over millions of hundreds of years. So they're slowly erupting, and on top of being slowly erupting, they cool slowly, so they're not creating a lot of damage. So once that magma comes up, it's lava, and it cools, you get new rock. And those rocks build up and create mountains and islands. Explosive eruptions. A volcano erupts explosively if the magma is thick and high in silica. High silica magma is thick and sticky. Think of something not like syrup that when you squeeze it and it gets it doesn't come out right. Think of, we talked about the end of the Elmer's glue, how the top kind of gets sealed, and then you have to squeeze it out, and of course that top's going to pop off, that glue that dried, and all of the rest of it's going to blow right out of the top. So it's thick and it's sticky, and it doesn't come out nice and slowly. So high silica makes it thick and sticky. This type of magma builds up in the pipe, plugging it like a cork in a bottle. Dissolved gases, including water vapor, cannot escape from the thick magma, and the trapped gases build up pressure until they explode. The erupting gases and steam push the magma out of the volcano with incredible force. That's what happened during the eruption of Mount St. Helens in Washington State. This eruption is shown in figure 3. So it's here, and then it looked like that in 1980. An explosive eruption throws lava powerfully into the air, where it breaks into fragments that quickly cool and then harden into pieces of different sizes. The smallest pieces are ash. Volcanic ash is made up of fine, rocky particles as small as a peck of dust, and pebble-sized particles called cinders. Large pieces called bombs may range from the size of golf balls to the size of a car. So what a variety that they can spit out. This is what the mountain looked like before, and this is what it looked like after. Kind of like that glue bottle that had stuff stuck on the top, and we squeezed it too hard. Volcanic hazards. I'm going to stop here, and we're going to continue reading later.